What about this? Which ones are smaller? Between test tube and boiling tube, which one is smaller? The boiling tube is bigger, right?
Make your collar properly.
Now we have this is the test tube rack. The test tube rack. The boiling tube is always on the bigger part. You see that bigger part?
Yes.
That's for the boiling tube, right?
Yes.
The test tube, the smaller ones, right?
Yes.
When not in use, when not in use, you can have it upside down on this, right? When in use, it could be carrying some specimen or reagents, right? So it is placed upright. When it lacks specimen, you can clean it, then you place it upside down, right? The bigger parts are from the boiling tubes, right?
Yes.
And boiling tubes, remember, you talked about test tube holder. Do you remember?
Yes.
Place it. You talked about test tube holder. We will come across them. What are these?
Test tube.
Test tubes, right?
Yes.
Okay, these are test tubes, right?
Yes.
I want to have them and then get them carefully in test tube racks, right?
Carefully. Hold them
Yes.
carefully.
Carefully.
Okay, just use the entire.
Like they can spread out,
You
right?
can spread out.
Yes,
I want
exactly.
to see, hold this, and I want you to do this. Kindly do this. This is how I want you to spread out.
So,
One person here, another one here, and make sure wherever you are, have test tube rack. Have a test tube. Have a test tube rack. Sir, that's good, right? Test tube rack.
Spread
Before you
out.
move on, what are these? Test tube holders. Can we hold a test tube? Can we try holding a test tube with this? Touch it. Class, can you see this?
Yes.
You can hold the test tube, right?
Yes.
In case you are eating something like this, you can use the test tube holder. Remember, the test tube holder can also be used to hold the boiling tube, right? Yes. They work together. So, make sure you have a test tube rack with you. This is the boiling tube. You may wish to boil something, you can have it there. So test tube holder can also be used to hold the boiling tube when you're boiling, right? You can boil something on which heating source?
speak out.
The Bunsen burner. The Bunsen burner. The Bunsen burner which produces how many flames?
Yes.
Types of flames, right? Which one do we prefer for heating? The what? Non-luminous flame. Why? Why do we use a non-luminous flame? Yes? Because it produces the hottest flame. It does not produce soot. What else? I have something here. What do you think this could? Have you ever seen this anywhere?
Yes.
What is this? This is a Bunsen burner. Can you see the chimney?
Yes.
You can see it. Can you touch it, Chachi? Touch the chimney. Touch the chimney. The chimney, only the chimney. Use your finger. Okay, touch the base. Touch the base. Okay, look, touch the chimney. Manfred. The chimney, right? Touch the base. And where do we have the air hole here? Where is it? Do you have a collar? Where's the collar? Remember, the collar is supposed to help us adjust between the flames by closing or opening of the hole, right? So let's look at this. Can you see what the collar does? It can close the air hole, right? When it closes the air hole and then we are heating, what type of flame will this one produce now that the air hole is closed? Can you see? What type of flame will it produce? Very good, luminous flame. What if it is open? What type of flame will we produce? Non-luminous flame, which is the most preferred for heating in the lab, right?
Yes.
So what do you think this is? We use this for the gas. The gas tap is connected to the valve, right?
Yes.
You see that gas pipe? It is fixed here, right? Then the gas comes in. This is the base, so that it doesn't topple over, right? We have this, the base. This for the gas inlet, right? Then we have the collar, and we have the chimney. Remember when we dismantle it in our diagram? This is the chimney, this is the air hole, and the collar that would adjust, closing the air hole and opening it. And then we have the gas inlet, right? The base for the stability, to support it, right? Now, this is mainly for chemistry, right? What are these? Some small spoons, right? What are they called? What do we call this?
Spatula. Good.
This is the spatula, right?
Yes.
Good. The spatula is used for scooping chemicals, right? You don't have to use your hands, right? You scoop the chemicals. Some may be so reactive. Whether they are reactive or not, they're supposed to scoop using the spatula, right?
Yes.
There's another one that resembles the spatula. We don't have it here, but you would have seen it earlier. It's called the deflagrating spoon. The deflagrating spoon. Can you see this?
Yes.
What is this? Let me hear. What is this?
Not bottle.
Rita is saying this is volumetric flask. Is she right?
Yes.
Why is she right?
Because
It has a what? Long neck, right?
yes.
What else does it have? A what? What is this? Girls who use earrings, you can know this better.
Stopper.
Good, this is a stopper, right? It has a stopper, it has a long neck. That makes it different from flat bottom flask. The flat bottom flask has a shorter neck and does not have a stopper. What is this? There's a mark, right?
Yes.
That is called a mark, whereby if you add a chemical here or any liquid and it reaches that mark, then it means that that chemical is exactly how many milliliters?
150 millimeters.
250 milliliters, right?
Yes.
You see, that's a standard volume, right? That's called a standard volume, right? Now, class, I've noticed something here. I hope each of you has access to these apparatus, the ones I talked about, right?
Yes.
Can we look at this? What is this? What is this? This is called the burette. This is the
Burette.
I know you may not know much because it's improvised. This is a crate. Whenever you don't have the one with the tap, we have some with the tap. You open the tap, then the liquid that is here runs out, right?
Yes.
So what I want you to do is take a burette, and tell me something unique about the burette.
You be careful, eh?
Just be very careful, right?
Very careful.
The burette has something unique.
Careful, careful, careful.
The burette has something unique in it. When you add a liquid into that burette or a chemical and it is full, you add any chemical, we have some somewhere. If you add chemical into that burette
You be careful with this.
and it is full, when it gets full, what does it read? What's the reading when it is full? 50. When it is full, what does it read? Wrong? I'll take this. What does it read for me too? When it is full, what does it read up there? It reads how many cubic centimeters when it is full? Now something unique is that when it is full, it reads 0. It reads 0. Can you see up there? When you add water, or I mean a liquid there or a chemical, and it's full, it reads 0, right?
Yes.
And that liquid will be added by some of you. In case you are adding a liquid, do you know what you need? You need this. What is this? It's
Some of the
called
substances are
the wash
kept
bottle,
safe
right?
at this point.
The wash bottle can be used. This is the one you can use. Give me the mouth. You can use the wash bottle. The burette with some liquid. Check. The clip is not here. Let's place it well. Is that clip well? I want you to feel that. Feel it. I want you to feel it. And then
Hey, carefully. You don't struggle, and not more than one should be holding an item.
remember, when you're feeling that, you need a what? You need a what? What do you need? You need a funnel, right? This is known as the filter funnel, right? That's the filter funnel, right? When you have the filter funnel, you can use that. Now, class. Remember, now, yes, you should have it here. You have it here. After filling, topping up to 0, you top up to 0, you remove the filter funnel before any experiment can take place, right? Yes, sir. Oh, thank you. Okay. We've been given something here. What do you think it is?
Microscope.
The microscope. We are going to engage you into this. You are going to tell me how we can use it to demonstrate, right?
That's good, yeah.
Yes. Now, class, what is this? What is this? This is the pipette.
Pipette. Pipette.
Now, the reason why I had to go for this is because you're familiar with this from your book, right?
Yes.
This is another type of pipette. You see this one? This is another type of pipette. It's another type. Not so common though. This one is not so common, right?
Yes.
So this is the main one. So the pipette also has a mark. Just like the volumetric flask, the pipette has a mark, right? When you look at this pipette, can you see up here? There's a mark. So you can fill the pipette. Some fill it using the mouth. But we have something called, it's a rubber apparatus that is made of rubber called the pipette filler. It's known as the pipette filler. So you can pull in chemical, you suck in some chemical inside. When it reaches the mark, you can always hold the other part with your thumb, right? So that the liquid
Concentrate.
cannot come out through this, right? When it reaches exactly that mark, it measures how many milliliters? 25. How many milliliters?
25.
Yes. So you're supposed to use the mark only because there's no other graduation. We don't have any markings, no scale. So the measurement should be exactly what is written there. 25 ml, right?
Yes.
So that's another type of pipette. You can check it out. Check it out. It is very delicate, right? It is delicate. I know you haven't seen conical flask, and you may be asking me when we ask the same thing. Now, what is this? What is this? That's a conical flask, right?
Yes.
Can you see the way it looks? When you're asked to draw the conical flask, will you draw a volumetric flask? You draw the conical flask, right?
Yes.
Yes. Yes. That's the conical flask. They are used together with the pipette, the burette, and something called retort stand. Called retort stand. Now I want you to look like you're conducting an experiment. Can you see this? This is called the retort stand, right?
Yes.
This is the heated stand.
Heated
Now I
stand.
want us to look at this. This is the stand. This is the box. This is the
Boss.
and this is the clamps. This is the
Clam.
They are used together with the burette, the conical flask. Used together with the burette, the conical flask, and then pipette. And then
Pipette.
how do you place it? Place there. And then we clamp. You can always use the balls to adjust the clamp up and down. So let's look at this. You can always clamp. You can always clamp your burette. Can adjust this. You clamp the burette. Yes. Do you want to attempt it?
Sorry, after the explanation, that is.
Yes, then you'll be able to do that.
Sure.
So, in case you have your funnel, you can use it to fill the liquid required here. You can use your pipette to fill the liquid required here, which is exactly 25 cubic centimeters, which is 25 ml, right? Mostly we use alkali base. We use alkali is a soluble base, right? No difference. It's just that alkali is a soluble base. So you can have it here, like sodium hydroxide is an example of an alkali, right? You can have it here, you pipette it here, place it, then add indicator. Indicator like the methyl orange or phenolphthalein.